switch off my video for now. Okay, good morning, everyone. Oh, good afternoon, actually. And thank you so much for having me here today to talk about my field of research. As Inga indicated, I work with statistical techniques used to assess renewable energy applications. And over the last couple of years, my focus has been on solar energy systems and in particular photovoltaic systems. And that's why my title for my presentation today is called The Sunny Side of Statistics, which maybe next time I can do the windy side of statistics, which is more appropriate for the weather today here in PE. Okay, so I just wanted to, because this talk today is a bit about emerging researchers, I just wanted to talk a bit about my study journey and how I ended up into this field of research. I registered for a Bachelor of Science degree in 2006, and obviously embarrassing myself with my age now, I might as well embarrass myself further. There's me in first year with my heavy backpack with all my books and my maths, stats, physics, and even a little bit of geology in first year carrying it around on campus. Of course, things are a lot different nowadays as they carry a laptop and or an iPad. So things were much heavier then. And they put a little bit, I look very young. Okay, so from there, I found that I was more interested in the analytics side, the more statistics side. So I continued with my honors degree in 2009. And as we all know, we have to do an honors project. And I thought to myself, what am I actually interested in? What do I want to do research in? Because I was more interested in the applied side of statistics. And I thought about wind turbines. They're really cool. And at that stage, there was no wind turbine farms in the country. And I thought maybe this is a different field for me to look into. So luckily with my collaboration or my undergraduate training, I knew someone in the physics department, Dr. Freddie Forster, and he actually had a data set with wind speeds at 5 different regions in the Eastern Cape. And this is what my honors project was on. And what is really cool now, just to say, I did the preliminary assessments of a very big wind turbine farm out of Jeffreys Bay area there in the Eastern Cape and also in the Clohessy municipality. So that's really cool to say that I was the first one to actually look at this data. With my honors project, I'm doing a literature review, which some of us think is very painful and long processes of reading journals. My supervisor, Professor Gary Sharp, and myself came across a number of articles complaining about the wind turbine noise. So I thought, okay, maybe I can look into this field. And so I registered for my master's degree in 2010, and my project was on wind turbine noise. And I remember giving a talk of how loud is too loud at one of my SASA conferences, and I think this just stuck with me for a very long time. During this year, I was able to also visit a large wind turbine farm in Germany, where I spent a month at the University of Oldenburg at their Renewable Energy Institute, where I learned a lot about how wind farms work and the different physical aspects of a wind turbine farms. Okay. So, like I said, I focus basically my honors and masters in wind energy. I just wanted to talk a little bit about my master's project and the importance of not just getting projects of where you already have the data. So for this project, I had nothing. I had to first learn how do I take sound measurements? How do I set up an experiment to collect this data? And what various statistical techniques I could use to analyze the data. So it was quite a broad project, and that's why I actually got on one of my co-supervisors, Dr. Frederick Forster from the physics department, to assist in guidance in some aspects that I might not have knowledge on. Okay, so from there, I decided to register for my PhD, and that I had to do part-time because I just started lecturing in the department here at Nelson Mandela University. And now I had to start my research project, and I decided to branch out a bit just to get some experience still in renewable energy, but a different aspect of renewable energy in solar energy. And this is where I'll be talking a bit more today about my research in this domain. And I thought this was a nice image that I created in Copilot. So it just shows you where the advancements of the different field, we can now generate images. Okay, so my PhD research actually started off, I wanted to look at cost data analysis of these big solar plants, but no one wanted to share the data with me. So that was the first struggle of the first year. Then I started thinking to myself, okay, but why don't I just look at the data and start playing around with the data in this domain? And I looked at simulated resource data from a package called Meteor Norm. And then I obtained actual measured data from an online database, the SARN, which is the South African radiometrics network, I think, and they actually store data from different sites in South Africa, and this is freely available data to collect. I then looked at comparing the simulated data to actually measured data, and I investigated various techniques, statistical techniques, to better assess this type of data. One of the methods I explored was multivariate profile analysis, and it actually was really quite a nice technique, and it fitted well, showing the differences in the simulated data and the measured data. Then also with my PhD project, the university was wanting to build a 1 megawatt photovoltaic system on campus, and they wanted to forecast and predict how much this plant is going to generate. So I now had to look at energy production from a photovoltaic system, and I used a software package to actually build and design this PV system. So when assessing the energy output of a plant, I thought to myself, perhaps energy generation from a photovoltaic system is very similar to that of a manufacturing process. So I thought, oh, okay, because energy from the sun is converted into electricity, and this where manufacturing process is taking a raw material and converting it into a final product. And in both these type of system analysis, you are looking at the variability of the manufactured items. And that's where I came about looking into tolerance intervals, and more specifically Bayesian tolerance intervals. So I was kind of already starting to think about using statistical techniques in other domains, and how do I use it in the renewable energy field. Okay, so PhD done, my job's done, I've achieved my goals, great. There I've also put in Professor Gary Sharp, he was my supervisor of my project, and yes, all sorted. Now I can start my academic career and let the next journey, my research journey, start, and developing into a more emerging researcher. Then I discovered, hang on, this mountain is growing, and then there's another one, and then there's another one, because what do I do now? Where do I go in my academic journey? Do I actually stick to the same field? So I started having questions to myself. I now need to learn how to supervise students. Okay, how do I go about this? How do I go about this? Then I need to think to myself, how do I appoint external examiners for these projects? Where do I meet these external examiners? Do I know people in these projects? Okay, so maybe I should then go to conferences to meet these people. Okay, what am I going to present at these conferences? It's important for me to actually go to national and international conferences. Okay. Next question, publishing. Now I need to, because previously I was working on a PhD project, I was having my little project, I could publish on my project on different topics, but now I've done with that project. I can perhaps continue with some aspects, but I need to grow my career further. And publishing is a very important part of my academic journey and my research journey in itself. But remember, with publishing, I then need to make sure that I avail myself to review publications. I remember reviewing my first published research, and how do you go about this? Because remember, publishing is very, very important of any academic's career. Then I thought to myself, right, I'm going to now need to learn how to supervise students, but I will need project topics. How do I come about getting project topics and data to go with these topics? Now, with any sort of research topics, the next question started to arise: grant applications, because none of the research can be done without money. You need money to attend conferences. You need money to actually buy software to obtain data. For me, I had very expensive, if I wanted to stay in the renewable energy field, I had to buy simulation software for these photovoltaic systems. And the other important part is we all know we need good computers to process data. We cannot get a normal 4,000 Rand laptop. We are in stages now where we need to do our data analysis, and we need to be able to sort this data out. And of course, luckily for me, I was on a Tutuka grant and I was able to actually apply for simulation PCs. But then I also had to think about, where do I want to go in my research domain? Do I want to stick with renewable energy? And then I thought maybe I should build a research team, because I do believe that research is not just done and isolated anymore. You need to have research groups, and especially in applied fields, you need expertise from the disciplines themselves. Then the NRF ratings. As a researcher, you want to be able to apply for rating and to get rating and to continue to be rated. But what is important for these ratings? So these were really the hurdles that I knew that I would have to deal with continuing in this field. So I realized from my undergraduate and my postgraduate qualifications that I had done a lot of work in the renewable energy field. And I knew that there was a growing concerns related to global warming, depletion of fossil fuels, and increased demand of electricity. And from my research that I'd done, I found that a lot of the work that was done in this field was done by the physical sciences and the engineering discipline. And the importance of statistics and even machine learning methods used to assess data in this field became very crucial. And I thought, you know what, I'm just going to stay in this field and I'm going to build my academic career in this domain. So this is my research team. It's myself. There I am with a hard hat, actually out in at a photovoltaic plant. Reason for a hard hat is because these panels actually track the sun, so they are movable components. I then also included my Professor Ernest van Dijk. He works in the Department of Physics, and he runs the PV Insight Group, where he collects various data from different photovoltaic farms in the Northern Cape area. And he also specializes in faults of photovoltaic panels. Then a lot of you know Dr. Warren Bretney, who is now a research associate of our department. He's also a part of my team, and he works on a lot of the supervision projects that I have with the students in past and current. Okay, so I'm going to give you a little brief overview of different statistical methods that I've used to assess data. And what I want you to come across is the importance of building on research projects, and not just conducting a project and leaving it alone, seeing where, at the end of your project, you always write your conclusion and future research, and how to build from future research. So I'm going to start talking a bit about building on from my PhD. Of course, I worked a bit with the tolerance intervals. And I investigated a bit about the bootstrap-based tolerance intervals, and I got a master's student involved in this project, and we were able to propose a methodology for the assessment of a two-factor nested random effects model. And we used these methods still in the energy field, where we assess daily energy yield of a photovoltaic system, and she was lucky enough to publish this in a conference proceedings. Then we built on this, where my next master student, he needed to actually assess the performance of this bootstrap methodology. He used a Monte Carlo simulation approach, and we looked at the alpha beta two-sided and the alpha expectation tolerance intervals, and we constructed them using a classical, Bayesian, and this non-parametric approach, and we obviously compared these different intervals. There's Christopher there, and next to him is actually the other student that I supervised, Valdo Abrahams, but he also worked with the solar resource data, but his project related to outlier detection in solar resource data. So yeah, I was working in this domain, and I thought, okay, assessing this resource data, you get a lot of outliers, but in the field specific, they didn't really have a technique to be able to detect large quantities of outliers. So we actually assessed in numerous methods, the KNN, naive Bayes, and the tree bag approaches. And what was very interesting is this project is you obviously got to train your models, but you need data sets that where you know the outliers exist and classified them before training. So we have to actually create data sets with outliers. So that was quite an interesting aspect of this project. I'm not going to go into too much of the details, but these methods really did work well. Yes, some graphical plots just to show you how they identified the outliers. And I think, yeah, where the circles actually represent misclassifications in the data sets. Okay, so from there, I've also worked with modeling the degradation of PV panels by looking at temperature. This I worked with the student Carmilla, and we actually published this in a conference proceedings, which I'll talk a bit about in this field specific, that this research is very current. So you try and publish it in a conference proceedings to get the research out there. It's also dependent, which sometimes publishing in this domain becomes very challenging because there's not many statisticians in renewable energy and analysis. So you struggle to find reviewers. So maybe out there, never shy away from reviewing a paper that might not be in your applied field, but they are using techniques on the data. So just maybe a word in there. Okay, so a bit about what I'm currently doing. At the moment, I'm working with solar power output predictions. Here's my new student, my honors student, who's indicated she wants to do masters next year. We're working on forecasting and assessing resource data at a solar plant in the Northern Cape area. I took a screenshot of the data that we're currently obtaining. So this is live data from a fully functional plant that's been operational for 10 years. So we are actually going to look into different aspects, which a number of projects can spin off here. We need to be able to detect whether there are faults in the systems, and we need to look at how to model systems where there was load shedding. We have gaps in data. So there's various different projects that we're going to be working in, but this is kind of what I'm working on at the moment. The last little project that I want to talk about that I've been working a lot in is fault classification from infrared images. This project actually started when I was chatting to Professor Van Dijk at an open day at our university, and he says he has image data. And he said, can statisticians analyze this data? And I said, of course we can. So we started off with looking at, this is the raw data and how it came. So you'll see there where there's red spots, that indicates that there's a fault in the panel. And what he had was a data set that gave the type of fault, and then we had given the raw data as follows. So we used various techniques, feature-based approaches, and CNNs to be able to classify whether a panel had a fault and what type of fault it was. So this is the paper that we published that's getting so much reviews. I think other than I checked it over, had over 100 citations already now, and it was published in Progress in Photovoltaics, which is actually not a statistics journal, so it was actually really nice to get out there in the applied discipline. Okay, the last thing I want to talk about is my PhD student. He's working in continuing this research in infrared classification. In his master's degree, he worked with variational autoencoders to expand the data sets, because remember, we had only 385 images. But for his PhD, he's actually got 4,000 images with 14 class faults. So, and he's now developing his own novel CNN architecture that's specifically designed for PV fault detection in this domain. And what he's also been able to obtain is a new type of image, which is an optical image. So we want to try and actually, which might not be included in his project, but we want to try and further extend this by doing some sort of layering with optical and thermal images. So I see my time is up, but what I wanted to say in this is kind of just a brief overview of the field that I work in. I work in renewable energy. I work with statistical techniques. I'm sure from the presentation today you gathered I'm working in various different projects with various different students, but I would love people to get involved in what I'm work with. I've put my details in here. I'll share my slides with Inga to share with the group. I have put links to my LinkedIn profile, my Nelson Mandela University profile, and my Orchard number, just to see where we can network further. I think this is a great platform to discuss further, and I know I'll be presenting a bit at SASA if this is still going on grant applications. I did go through the full NRF to TUCA. I obtained a grant, the rating track, the NRF PhD, the postdoc track, and then the rating track. So I'm hoping to share my experience in this field. But I think that's all I have time for. So thank you very much. Looking forward to some questions.